Hey, Andy.
Good morning, everyone, and thanks you so much for joining us today. I'm Chloe from the Tri-County Regional Energy Network, and today we're joined by Jennifer and Mike for our Higher Performance Residential Remodels class. And before I hand things over to them for the training today, I have a few logistical and background slides to go over. Jennifer, if we can go to the next slide. Great, thank you. Please remember to stay on mute for this training. It really helps all of us be able to hear the presenters. If you do have any questions, you can go ahead and add them to the chat. We will be monitoring that and pausing periodically to go over questions. We are recording this training, and the recording and slides will be shared with you within a few days. And we're also going to be sending out a survey with that email that has the slides and the recording. The survey is really short. It only takes us a few minutes to complete, and the feedback really, really helps us out. So if you have time to fill it out, we really appreciate it. We are the Tri-County Regional Energy Network, aka 3C-REN. 3C-REN is funded by ratepayer dollars that we all pay into in our utility bills through the public goods charge. And the benefit of being ratepayer funded is that there is no cost to those that we serve. And as a regional energy network, we are able to return these dollars back to our local economy, which has historically missed out on some of these funds. You can go to the next slide, Jennifer. Thank you. 3C-REN currently offers 6 programs that are focused around 3 services. These include incentives, training, and technical support. Today's training falls under our Building Performance Training program. To see more of our upcoming trainings and learn about our other programs, you can visit 3cren.org, 3c-ren.org. Go to the next slide. 3C-REN is so proud to have offered trainings attended by over 4,000 individuals since 2019. And we are excited to see all of you here today with us to continue growing in our mission to promote high-performance building and energy efficiency on the Central Coast. And with that, I'll pass things up to Jennifer and Mike for today's training.
Thanks, Chloe. Hi, everybody, and welcome. I'm Jennifer Rennick. I'm a licensed architect and a certified energy analyst. And with Imbalance Green Consulting, we wear the hat where we're doing trainings for 3C-REN. And today I feel so lucky because I've got Mike Horgan here with me, who is a local builder to the San Luis Obispo, California area, passive house certified, and is very knowledgeable on building and energy efficiency. So, Mike, welcome. And then
Hi.
coming up, we're going to switch, and then Mike will drive and we'll do zero net energy from a builder's perspective, and I'll be the guest. So today we're going to really focus on remodels. And we're going to be looking at better performance and some opportunities, and specifically kind of hit into some of the areas that touch on heating and cooling, hot water, and appliances. We'll touch a little bit on the envelope, window walls, attics, floors. We have some examples to go over, and then we'll round out with solar, PV, and batteries, and just give you an example and a little bit of what you can talk to your clients about and kind of client expectations. Learning objectives for the architects out there: get their AIA units. And with that, we'll get started. So some of the pictures we're going to be showing are from a project that Mike was doing as a major remodel. So much of a remodel, it's almost like new construction, I would say. But that does come up. And then we also have examples of projects that did not take on such an extensive remodel job that we'll go through. But when we talk about kind of that ideal of remodels versus new construction, no matter what, we want to hit on kind of these 5 major principles. And a lot of time they're known as like the passive house pillars. So we're looking at, for our quality envelope assemblies, we really want high quality insulation. We want to eliminate thermal bridging wherever possible, and we want to minimize air leakage. So that's something for whether it's the ideal kind of new construction or the reality of remodels. We want to do that wherever possible. And we want to look at strategically placed quality windows and balanced ventilation systems. Today, we're not really going to get into the balanced ventilation system so much, just give you kinds of heads up because we've got, we'll touch more on that, I believe, on the new construction, but it does come up on the remodels. And then we are kind of adding to these pillars, really looking at energy efficiency, hot water heating, HVAC in our appliances, and then the solar battery and PV. You do all those things together, that's kind of the ideal. You would hit every one of those in new construction. But what about our remodels, the alterations and additions? It's not always the ideal. We like to follow kind of a what Mike calls a NEPO plan, where you look at what's the need. And after that, we establish what we're really going to be able to target. We come up with a plan for reaching those targets. And then we want to also look at our objective, really, of why. So when we're doing these remodels and doing the evaluation first, we really want to consider what the owner has concerns about or is complaining about. We're going to be looking for visual clues like lack of insulation. We can use infrared photography for that, kind of the age of the windows. We also employ our nose and we look at, or not look, but I mean smell. Do we smell mold? Do we smell mustiness? We can use blower door testing, duct testing, look at existing utility bills, kind of take a look at the existing fuel sources. And sometimes we employ full-blown energy audit. So in one case, we show that blower door test is being used kind of, we evaluated the house before, I believe, Mike, and then evaluate the house after the construction.
That was one of the first Enerfit projects in California, actually. That middle photo. That was in Rolling Hills, Los Angeles. That was one of the first projects I did in California. That was a fun one. That actually has a photo of the HRV system right there on the wall in this remodel. So.
Oh, right. And then we'll have another picture that shows that. Yes, which is a localized energy heat recovery system. And then we can also use, smoke tests and see where the currents are in an existing house and kind of evaluate it that way. So there's a lot of options and there's helpful tools. So I just went online this week just to kind of double check what the price is on some of these tools. And the one in the middle, you could pick up, it measures temperature. We'll show examples of using that. You could pick that up at Home Depot for around $14, $15, but you can also spend as much as $120. That's typical. And then there's several options for doing infrared photography. You can have FLIR, for example, that communicates with your smartphone. It's a handheld camera, or you could get all in one for much more money that you're able to point and shoot at the areas and then download that onto computer. And then more and more I'm seeing kits and also building energy auditing folks using gas sniffers, especially with the combustion fuel, just to figure out what's going on there. And then I thought this was pretty cool that True Tech Tools now is offering their building performance BPI kit. And that's a really good price for only $4,800, but it includes the sniffer and the thermal imaging and the blower door tests. Anything you want to add on those tools, Mike?
No, that's a great price. $4,800. That's what it used to cost to get a blower door itself. So that's awesome.
Yeah, so they're putting together a good kit to really help out in this department. So kind of that's our kit. Those are some of the concerns we look at. Now, when we try and figure out what do we want to target in a remodel? What are we really after? Kind of what are our aims or objectives? I mean, one of the things I look at as the energy analyst is what systems in our homes are typically using the most energy. And it is combined space heating and air conditioning, which ties back to the envelope, but also the equipment itself. And then the next big bucket is water heating. And then we get into this realm of appliances where refrigerators actually can be a big deal. And then the cooking appliances, not so much. This is all electric, kind of average in the US. Clothes dryers, electric clothes dryers are fairly large energy use, but it's all relative. It's incremental. The biggest ones would be our space conditioning and our water heating. And then after that, the appliances. In California, we have a slightly different mix where we have a lot of gas use in our houses. And so the water heating, now when we look at it, including gas, the water heating, that 28% is taking a bigger chunk of the energy pie because so much of the heating is natural gas, and same with our space heating. Give you kind of an idea about this. This is from a local person's home. They'll tell us if it's okay to mention their name, I guess, in the chat. But this local person has a monitoring system on their house where they can start to look at their energy use. And it turns out for this particular homeowner, it's the beloved spa that was a big energy use. So if we were doing an energy audit on this house, we would look at that and find out more if there was something to perhaps help them save energy, or if that's just an acceptable energy use for them, and they use their solar energy potentially. And eventually, if they get a battery in their house, they could use that solar energy, save up some of that battery, and go back to the spa. But it'd be a robust system to account for the spa. So it was approximately 29% of
Can I
that.
pop in here, Jennifer?
Yeah, absolutely.
Two things. As we move through this, I try to think from the side of, well, Jennifer and I wear lots of hats. We wear the consulting hats, the teaching hats. I'm also in the field just about every day, not every day with the tool belt on, but almost every day. So shout out to my team that is in the field, and particularly Hannah, our project manager, who's helped gather some of the information for these slides. But as we talk about these higher performance remodels, and we're pushing towards electrification, and a lot of this stuff has passive house principles. As you're talking to future clients, I'm assuming most of the people here are architects, maybe a few builders as well. But from the perspective of a builder who hates sales and the idea of sales, we still have to sell these projects to clients. So you have to be thinking about presenting these points in a way that doesn't scare them. So as we talk about higher performance, we're not talking about getting rid of the things that make people love a home. So Andy loves a spa at her house. I have a sauna at my house and I use it almost nightly. So we're not trying to get rid of the things that make home home. We're just trying to make the home itself better and keep the things that we love and make the rest of it perform better as well.
Yes. Yeah, well said, Mike. That's true. And so, yeah, the spa
Thank
is
you.
not going anywhere. Here's Andy. Yeah, go ahead.
No, I appreciate that. Thank you. And this is it's a great lesson learned for us in terms of thinking also about time of use and utilization. And so, yeah, good process. I appreciate that.
And then, like so many homes, then there's like this 39 to 40%, and Andy's house is kind of right in there that's basically everything else that's plugged in. When you take away, her mini splits, and which includes her hot water heating because of the type of system she has, it's all part of the heat pump system. And then everything else is all this plug loads. And that's really, it's pretty typical, but this is one way you can monitor a system. So I wanted to point that out in this energy pie, that it's going to vary depending on the individual household. And in California, the reason this is why I'm making a point of it is because part of the discussion in remodels a lot of times will come up for fuel switching, because many of our appliances in California are natural gas, but a lot of our clients and a lot of folks that are moving towards energy efficiency and energy independence and resiliency, they're really considering solar, and new construction. You have to have solar. Remodels, absolutely, solar's required, but many people who can afford the remodel are also then looking at, should we get solar, should we get battery? And to take full advantage of that, it often makes sense at that point to convert some of the existing gas appliances to all electric appliances, including your space heating and your water heating. But just be known that, 64% of the homes in California are going to have, natural gas, and only about 8% of our homes in California are all electric right now. So some of those energy consuming systems that have energy efficient electric options are going to be our HVAC system, ducted and ductless, mini splits, domestic hot water with heat pump water heaters. We've got ranges, cooktops, ovens now that are induction and electric. We'll show you really great couple examples of that. And then our laundry clothes dryers also, we have electric versions, but condensing and heat pump, they're slightly different, both ventless, both more energy efficient than your standard electric resistance. And we have a couple examples of those. So one of the first things we're going to really look at is kind of when we get a remodel project is the building evaluations and trying to identify the occupant needs. And so do we want to begin with an energy audit or at least an evaluation of the energy systems? We say yes. Yes, we want to. But sometimes that could be as straightforward as the architect with a certain level of knowledge, and they're armed with maybe an infrared camera, and they understand the building heating cooling systems, or maybe they bring in an energy consultant or a knowledgeable BPI or builder like Mike. They've got HERS raters out there who could come and do some analysis on the project for you as well. But there's ways to kind of get a handle on that project for your client. And then some of the top kind of strategies and talking points is, you're going to hit it maybe from the energy savings perspective, if that's the reason your client came to you. So you talk about the HVAC upgrade and domestic hot water upgrade with pipe insulation and insulation upgrades with air sealing. Okay, so that's kind of one bucket. But there's also sort of the comfort perspective and aesthetic and design perspective. So this picture on the right is from a house remodel that we worked on, where really the whole thing was all about the owner, mostly the wife in this case, really wanted the certain aesthetic, and it was everything about better daylighting, and she wanted better lighting in the kitchen. She had a particular look she really wanted, and the husband was really interested in how to make the place more comfortable, but had always wanted to have the house more energy efficient and add solar to it. And so kind of working both these angles of, or all three of these angles really, of energy, comfort, and the aesthetics, we're able to get their whole kitchen remodeled, but at the same time, redo their attic insulation. They did a fuel switch to mini splits, and We just addressed as much of this as they could, and then they got a solar PV system on the roof. And this picture right here, this is that same house Mike was talking about, and this is the client for the house where they're figuring out where to place the localized indoor air quality, ERV, HRV, Lunos vents through the wall. And really a lot of this, Mike, if I remember correctly, a lot of this was from the health perspective, from looking at how you control the outside air, how you deal with getting fresh air into this building, and then that resiliency and durability perspective. And you ended up insulating the exterior of the CMU, both for the energy, the comfort, but it was also part of this bigger picture, correct?
Yep, we used an exterior wood fiber board around the CMU house and installed a series of these HRV air filtration fans throughout the house. And a lot of the reasons for the HRV, one, they wanted to get Enerfit. They had some folks have the idea of passive house in their head and they want to get that, and they want the stamp. Some folks just want a higher performance home. In this case, they were actually going for the certification. We put these in all of our homes, even if we're not going for certification. And the driving force in this one outside of the certification was smoke mitigation from wildfires in California. So with these HRV systems, they come with different level MERV filters, and even if you're in uh, trying to use words carefully because there's a lot of people affected pretty heavily by stuff right now. If you're in a smoke or fire area or vicinity, and you're inside one of these homes that have been built to a higher performance, you generally, no absolutes in the world, but generally your house will not smell like smoke if you're operating an HRV system and don't have your doors and windows open. So it's just another one of many reasons for these to be used in projects.
Yeah, really good point. And then the other thing, part of moisture mitigation is sometimes, and we have today, we're going to talk a little bit about this, the example of raised crawl spaces. And so there's opportunity there to address those raised crawl spaces for moisture mitigation, and also part of the resiliency and durability perspective. Okay. Yeah, kind of diving in, we're gonna, on the heating, cooling, we talked a bit about the ventilation side of it already, but you know, when you go to a project and you're looking at the equipment, HVAC gas or AC is this an opportunity, or do you leave as is? This is kind of the way I'm framing these as you go through, because this really reminds me of what it's like when I first get on a project. And this picture was for a house. The folks wanted to remodel it, and I asked them where their heating system was, and they said, oh, here it is. And they opened this closet door, and here they had a couple of different furnaces in this house, but this was one of the furnaces. And believe it or not, in this old house, that door opened right up onto their bedroom. Okay, so in my mind, one of the first things we're going to look at is that indoor air quality. It's where is this thing located? And really, after we're done with this remodel, do we want to keep a furnace right off the bedroom like that? And I would say no. So they weren't really thinking this should be part of the remodel. But in my opinion, this should very much be the remodel. So then we can talk to them about the benefits and energy efficiency, et cetera, et cetera. You know, so potential solutions and all these things is, do you leave something in place? Do you repair it? Or, you know, do you remove it? And do you remove it and replace it with other equipment like a ducted heat pump, all electric, or in this next case, a dual fuel system, which basically means it's a heat pump with gas backup. So this project is up, it's this particular project's located in Oregon, but it could have been in the northern part of California or more in the mountain areas where it gets cold enough in the winter that it snows. But basically what happened is that the owner's furnace was on the way out. So they needed to do some replacement and upgrades anyway. And at the same time, they wanted to depend less on fossil fuels. They wanted to go heat pumps, but they weren't sure if a heat pump was going to work for their location. They kept going back and forth. They were scared because of it being cold outside. So this solution seemed to be kind of the best for them, which is essentially they were able to keep with everything within the same brand, same line of appliances they had. And they got an upgrade on the furnace part, but it now connects to a new heat pump on the outdoors of their house. And that heat pump is what operates most of the time. And I was there this winter and saw for myself, even with snow on the ground, when the heat pump would kick on, when it was time to call for heat. And you could see it, the fan would turn on and a little bit of snow would blow up like that. And then it was running in heat pump mode, and it was 26 degrees, close to zero, and the heat pump was still operating. So I could tell you that that furnace doesn't run that much, but this kind of a combination, it made the clients feel really secure and happy. And
And
so this was their,
hopefully we're all past the idea. I think I asked Andy the other day to figure out how long we've been doing these workshops, and just Jennifer and I have been doing these together for 5.5 years now, but we've both been doing this for decades longer. Hopefully everybody in here is past the notion that heat pumps don't work when it's cold out. That's really just an urban myth, like the Blair Witch Project. I'm from coastal Massachusetts on Cape Cod, and have been putting heat pumps in all of our projects since 2007, before I moved to California, including my own house, covered with snow. They still work well. Lots
yeah,
of our friends back in Maine and New England and Vermont, this is what they do. So hopefully we're putting that myth to sleep now.
right. But you're talking about the reality of remodels and the reality of owners. And so I just am like, it could be an option. It's here. Um, and they made it, I mean, the company has all this, it fits together, it's meant to go together, it installed easily, but it does make them happy. So, but this is more what we're talking about. Hey, this is my own project. My furnace was abandoned. It had a cracked heat exchanger. The ducts were in terrible condition. And so I had the mini splits put in. I have a raised floor. This whole thing took about 3 hours for them to install. I'm not kidding. They did 3 indoor wall-mounted units for the bedrooms and 1 in the living room, and we were good. We were done. It's really straightforward for remodels, and it's a great time to fuel switch. Example, this one here, some of Mike's projects where they use ductless recess ceiling. And, similar thing where you could have a project where their furnace is at the end of the life. And in a lot of cases we're seeing, and in my case, I had a furnace, but I didn't have air conditioning. So I wanted to add air conditioning anyway for the cooling. So again, the heat pump makes all the sense in the world because you could get both the heating and the cooling and deal with the furnaces being at their end of life. And in this case, if the ownership doesn't want wall-mounted units, there are these recessed ceiling. And Mike, you have a picture on the right there. We're basically kind of showing where that's located, and
Yeah, we make if anyone's wondering how to address these things in the field, we'll actually get the specs of the ceiling units. We'll download the specs, and we'll actually just make a quick mock-up with plywood of the size of that unit of the actual unit, because the motor itself is supposed to fit between 16 on center framing, but we want to make sure the clients understand the size of the cover that's going to be on the ceilings. So we'll make a plywood cover and we'll go around the house and actually mock up where we want to install it. That particular photo is that's a 1900 square foot house, and we were initially going to use just a single 1 ton ceiling cassette on the first floor, and that would have been enough for the efficiency of the home from our brain, like from Jennifer and my brain. It would have worked. Um, but going back to what we said at the beginning, we still want to balance all the needs of the clients, and it might not be needs, it could also just be wants. They are going to have 2 teenage boys in a couple years, and so the teenage boys got separate units in their bedrooms, as well as separate air filtration systems in each bedroom that will hopefully let the parents have some comfort. Yeah.
You know, that's why I put them in the 2 kids' bedrooms in my own house.
Yeah.
Because I had the teenagers, and so they got their own units, then whatever, that. And then I only needed the 1 indoor head for the whole rest of my house. Now, my house isn't that big, but that 1 head does my kitchen, living room, and the other bedroom. That's all I needed. Yeah. So
Jennifer, before we go
Yeah.
too far, Ellen's got something that we should address now. So the question is, how does the efficiency of the ductless compare to the mini splits? Um, Mini splits can be ducted and ductless. So a ducted and a ductless system both have an outdoor condenser compressor. The term gets used interchangeably, and then they have another one inside. And the difference between the ducted and the ductless is that from the inside unit, with the ducted, you now have ducts that distribute through the house. The ductless is just that one head on the inside. And it comes down to more about particularly in remodels, the accessibility of getting ductwork through a project. On a new home, it's easier where you're able to start from scratch and design with, say, floor trusses, or you've got ceiling and roof trusses where you're pre-planning for the gaps and the spaces in the framing that you'll need to move ductwork around. Whereas in remodels, we find we're often not taking the ceiling of the house off, and there's already a limited square footage, and clients might not want to give away that square footage for a duct chase or a soffit. Hopefully we're doing away with soffits now because we don't need to. So we end up using just the ductless more often than ducted for space purposes.
Yeah. Okay. And then that's great, Mike. And then I saw another question come through. I can kind of answer that question as I go over this slide. This just when you're doing the ductless systems, and you're looking at how they should be installed and be mindful of your air barrier and where that thermal barrier is, whether it's new construction or remodel. There's a couple of things to keep in mind. So as architect, as you're kind of working through a project, if you're dealing with a vented attic and they want the ceiling recessed, then you should call out or at least detail or show that there's needs to be some kind of like drywall box that's taped and sealed that's part of the air barrier that keeps the ceiling insulation off that recessed unit. And then if you're doing all the insulation up at the roof deck and going a route, maybe now you're converting to an unvented attic space, you can then have that attic floor, your ceiling free and clear. And it's really easy to run the refrigerant lines and get those ceiling recessed units in there. And then the cassettes, the indoor cassettes that are ductless, they have small filters on there that you clean. You can take them out and rinse them. You put them back. It just kind of helps catch big pieces, dust, debris inside the house. But the MERV 13, quote unquote, filtered air for code that's required, that's when you have an air handler pulling air directly from outdoors, or your HRV, ERV, indoor air quality fans. Those will have the MERV 13 filter on it. But this is just addressing space conditioning and not bringing in the fresh air. That's the one thing with the ductless systems, is now your fresh outside air is a different system than your heating and cooling.
And just to go
Here-
back to
yeah.
very foundational aspects, just in case so we don't get too far ahead. It's like using acronyms when not everyone in the room knows the acronyms, but the heating and conditioning systems are different systems than your air filtration and HRV systems. And we'll talk about them separately. So we're just talking about the conditioning spaces now. These are not providing filtered air to a home. Think of it as if you're in your car, you have your car conditioning system on the recycle system. It's using the same air that's inside the house already. The HRV, fresh air filtration, or a fully ducted system, those are different mechanical systems that we talk about separately.
Right. And we really don't have time in this course to go over all the different ways to bring in fresh outside air and that whole system. But on the 3C Ren website, we do have links to the prior classes we have done on the HRV, ERV, indoor air quality, and love the like. And I believe when we do the ZNE from a builder's perspective, we'll hit a little bit more on that system, because it's part of the whole package for when we talk about zero net energy. Okay, so that kind of addressed like this big bucket of space heating, space cooling, and sort of the what you want to look at, and is it an opportunity that gets wrapped into this whole remodel? And the water heating and the appliances are kind of a similar thing. This is a brand new heat pump installation that Mike had done on one of his projects. And just, that's kind of what they look like, with the condenser on the top and the tank on the bottom. And they do need plenty of air circulation, which we'll talk about in a minute. But for the most part, they install very easily, just like a tank type water heater, of electric tank type water heater. Much easier to install than a new gas tank type heater, because there's no flue and no gas piping and no carbon monoxide or anything else you have to worry about, since the system's all electric. Okay, so now in California, what you might find is when you go to a home and you're taking a look at what their hot water heating system is and trying to figure out if this is an opportunity or you leave as is, you might come across existing tank electric water heaters. And in one case, I came across a tank that was leaking at the base. So that seems like a no-brainer. You're going to change that to something. And then there's also a tank, but it's a fairly new electric tank. And so the ownership might be thinking, oh, I just got mine replaced. Why would we want to switch it out? And the only reason you might hear on this new case is because the heat pump water heater will pay for itself within a few years. They're very energy efficient compared to an electric tank. So this is an opportunity, and if they're trying to go solar and reduce their energy bill, even though they may have recently replaced their tank for a few $100, the other will pay for itself. So you're going to look at functionality, kind of that age efficiency, location. Now, location, I have another slide for us to look at, the one after next, where we're going to hit a little bit on location for the heat pump water heaters. And then the sort of same question is, do you leave it? Do you replace with the same kind or get a heat pump? And same kind of question comes up with domestic hot water, gas tank or tankless. In, for this project, this was the condition of their existing gas tank. They recently had a little bit of repairs kind of done on it, so it seemed to be working fine. So the ownership wasn't that interested in changing anything because of the cost. But if they're so inclined, there is the opportunity as they move towards all electric that the heat pump water heater would be more cost effective than a tank gas water heater. However, an on-demand gas water heater is going to be about on par energy costs with a tankless, with the current pricing of electricity and current pricing of natural gas in our area. And so now you're kind of up against what are the owner's true desires to move away from gas. They may not choose to. In my own house, that's the last appliance in my house that has not been switched out. And it's precisely because the cost to do all that work isn't something that's going to pay for itself, because I have the tankless system that is functioning well and it's fairly high efficient. So those are kind of the questions you might have. If you're in a situation where you're redoing all those systems anyway, and you're going with a heat pump water heater, do you want to keep in mind that the integrated type, not a split system where you have an outdoor condensing unit and an indoor tank, that can function in very cold weather. But if you do this type, which is the most common, the integrated type, then you need to just keep in mind that there is some sound that comes off of them when that compressor kicks on. So be mindful if it's near bedrooms. And there is condensate that comes off of the heat pump. It's like the same kind of water you get off of a glass, cold glass, the water on the outside, it's just condensed from the air. Just the same you get from an air conditioner. In fact, that compressor on the top of the tank acts like a little baby air conditioner. So it gives cold air conditioned coming out of the system, and it takes the heat it pulled out of the air and puts it into your hot water tank. And there is a certain amount of volume of space that's needed around the systems in order to function properly, or they do come with duct kits to get around that. We're not going to go into all the details on the heat pump water heaters today. We've got some other classes for that you can listen to, because we could spend a whole hour just on the heat pump water heaters. But keep in mind, they're going to function better in temperatures that are above 45 degrees Fahrenheit, but some of the newer models, 37 degrees Fahrenheit. They should be located within a utility room, utility closet inside the house, or in your garage, because these are not rated for outdoor exposure.
And these are great. Some of the points that Jennifer just made makes these great to put in a garage. If you got an old unconditioned garage, great spot to put a heat pump water heater.
Yeah, especially if you want some air conditioning in the summer in that garage. Okay, and then kitchen remodel, kind of that next, we hit the big buckets of energy use things in mechanical systems in your home, and then comes down to your kitchen and the cooking. So induction is great. I love using induction to cook with. It heats up like that. There's kind of higher end looks where you could get this retro look now that GE Cafe offers, or if it's a budget, Frigidaire has their induction ranges. Look for them on sale, because those sale ones, and it happens fairly frequently, are priced to be competitive with the gas models. And then of course Energy Star refrigerators, like LG, for example, has a refrigerator with their inverter technology. And so their inverter compressor means it's basically a variable speed compressor, so it gets a lot more energy efficiency. And then kind of case in point is two kitchens that Mike worked on, and he can jump in and add a little bit more, but the one on the left uses the more affordable kind of appliance package. And then Mike, the one on the right, you said was a conversion of an old stove. Is that correct?
Yeah, these are two projects that we've just completed in the last 6 months. One is a new construction. The one on the left is a new construction. So the example is just to show you that uh, even doing an induction cooktop or a range, it doesn't have to break the budget. That kitchen on the left we've used as a good example of a really budget kind of design and installation, and that's an $11,000 all in, including cabinets and appliances kitchen. So including everything, including the induction range, that's an $11,000 kitchen on the left, including the cabinets. And the one on the right is an interior designer's home. So we did not do the interior design for the one on the right, but we've done the design builds on both of these. So Serena from Design Collaborative did the design on the right hand picture. That's her personal home. And that stove is, we're working on telling the story now, but I believe that stove is a third, possibly fourth generation stove that's been handed down in her family, originally a wood burning stove. And Serena and her husband found a shop in San Francisco who are converting these old stoves to induction. Uh, I don't know the total costs. I do know it was probably about 50% of the total kitchen of the photo on the right just for that stove. But we're all working with different categories of incomes on our projects. And that one was a love-driven installation, but that's a pretty magical induction stove on the right hand side. That's I think that thing's 100 years old. I'm not sure, but so it's possible. The idea of showing these pictures is showing that's possible. You can have an $11,000 kitchen, or you can have an $11,000 stove and a beautiful kitchen as well. But they're both all electric and both induction.
That's awesome. Okay, before we go into the laundry, I saw a question on the heat pump water heaters. Mike, can you take a quick look at that question, and then after you read it, you can stop me and I'll answer it. But I'll hit on the couple laundry slides first, and then answer the question. Laundry remodel, same kind of thing for energy efficiency. There are some newer models of dryers that are more energy efficient than the standard electric dryer. Here's one of those things too. If they already have a gas dryer that's well functioning, it may not be kind of cost effective to change it to the newer dryers, but perhaps they want to get away from having fossil fuel, or they may notice like that odor or something from using gas dryers. Like I noticed that on my old gas dryer. So I wanted to get rid of it. I just didn't want to have burning gas in my garage anymore, is where I had my dryer. So I went to the electric, and they have different types, but the non-venting, condensing, or heat pump dryers, you got to know that they do need to be connected to the drain hose like you would have for the washer as well, because of the nature of it being a condensing type of unit. There's going to be condensate, and you can there's also a filter. They have self-cleaning and ones that you have to manually do it. So I'd be on the lookout for that. And what it also means is that, like all the other heat pumps, they need a lot of air circulate. They need access to the air in the room, because what they do is they pull the heat out of the air in the room, but also mostly they're taking that air, they're condensing the water out of it, and then using the drier air to dry the clothes. And so if they don't have access to enough air, they don't function as well. So case in point, this is from my nephew's apartment, and the apartment building did a massive remodel, and they made these larger bathrooms with utility laundry alcoves, and they used solid doors, and he would put his clothes in there and close the door, and it was basically cutting off the air circulation, and so his clothes weren't drying. And he called me up, and he's like, do you know about this stuff? And so we troubleshot it, and then we figured out, oh yeah, you know what, they should have, and these were Bosch units, they should have left the doors off. They should have used maybe louver doors, or you have to get in the habit of keeping the doors open when you're actually doing the washing. And that took care of it. And so I just give this to you as like a cautionary tale, that when you do work with your clients for these units, just keep in mind, heat pumps, like the water heating type, needs enough circulation so that they function properly. Okay, Mike, before we get into windows, walls, attics, what was that question about the heat pump?
Question on code requirements for non-split heat pump water heaters. I only know of two systems that are split heat pump water heaters. So we've installed one, but largely we do the non-split. Aren't they required by code to be installed in conditioned space?
No, the unit themselves doesn't have to be in a conditioned space, but the unit has to be inside a structure. Every once in a while, you might go online and you'll see like people will install these outside their house in a super mild climate, like in Hawaii or parts of Australia. But you're right, code doesn't allow you to just install it outdoors. It has to be inside something, because they're not weather rated, they're not weather protected. They're going to function better if they are inside, and we always insulated space, but has plenty of air accessible, that gets down to that 450 cubic feet to 1,000 cubic feet of air that it needs. If on your Title 24, however, on your Title 24 report, if the person who ran that report for you and they clicked the button that says this is being installed in conditioned space, then yes, per that requirement on your performance Title 24, you may have to make sure it's installed in truly conditioned space.
And we're only about, I'd say we're 75% even, or 25% of our heat pump water heaters even go inside. We're inside the envelope of the home. We're about 75% where they're outside the envelope of the home. And we generally design a small shed that looks like it's part of the design on the outside of the envelope, and it goes inside that shed. And we have louvered walls or louvered doors, so it has its airflow.
Yeah, and then we're seeing projects where we've got utility closets that the ownership wants solid doors. They don't really want to have the gaps and the louvers and all that. And then we're using the duct kits.
And we've
So
done
that
the
you get
duct
that
kit.
air.
We've done the duct kit on one project too, which adds a little bit of task to the process. I want to make sure when I say we're designing a shed, we're not designing a additional expense, because I know the pushback. People hear this and they go, "Oh God, now we're going to design a shed." No, we're building a very quick structure that takes a few hours to put together. We can get as extravagant as we want on it. One time we repurposed a metal shed from Cal Poly and attached it to someone's house in downtown Slough. The other times we've been asked to build some really pretty ones that match the design. So it's just a box that protects it from being rained on effectively.
Okay, so existing walls, existing windows. Yeah, okay, remodels. Is this opportunity or leave as is? You know, it's one thing if you're tearing into the thing and punching it out to maybe do an addition. Or in this case, there was this particular house. It was a house that had 4 corners. And the idea was just to keep all the remodel within those 4 corners, save time, or, you know, save some money. And one of the questions we had for them was, did they know how much insulation they had in the walls as we were working on doing some preliminary energy modeling for them? So the owner goes, oh yeah, let me just check. And I said, just cut a small hole just so you can peek in there. So he cuts a small hole and then takes a look, and he doesn't see anything. So he gets kind of mad and he rips the wall open, and he's like, oh my God, my house isn't even insulated. So he didn't realize that in a couple of years he'd lived there, this house, and he was like, oh, aha. He had an aha moment on the old house he bought, that no wonder it wasn't very comfortable. So anyways, you just never know what you're going to get, is what I'm saying. And so we're going to show you a couple of pictures, like if that's the case and you're really going to redo the interiors, what some of your options are. Also, single paned windows. Clearly, you're going to be more comfortable if you update those windows. And what does it mean if the frames are wood or metal or you know, another material? And then, of course, there's solutions for improved wall insulation. And do we leave something in place, or are we talking about removing or replacing the windows?
And we're going to show you some financial numbers. So this is a
Oh
fun
yeah,
thing to
yeah. And
really
so
pay
for the
attention to.
windows, you know, existing. So this is the space I'm renting right now. Existing windows. They're non-thermally broken metal frames. It was not even that warm outside. The interior wall was registering at 66°F. And this is that handheld instrument where you can measure temperature. You could pick one of these up like Home Depot for like $15. But at the metal frame itself, it was registering 104°F. So, you know, and that is a really good indication of what that temperature is on the outside of the frame. Heating that metal up, that color, when it's in direct sunlight, it's radiating 104 degrees inside the room that we're trying to keep cool. And this, though, is, yeah, we could say, oh my gosh, you should replace your windows. But what we're seeing is in homes that have the ability to accept sunlight through the glass and maybe have the frames that radiate this heat inside it, like my little dog Sparky. He finds the warmest spot in the office, winter or summer, and he likes to be warm. And so what has happened to homeowners, they get the new windows with the thermally broken frames, the low solar heat gain coefficient glass. They're more energy efficient, sure, but now they're unhappy because they've lost their favorite, you know, sunny, warm spot. And keep that in mind when you're managing client expectations, and really asking the questions of like, what do they like? What are they using? How do they use their house? And it's important, and also to have the improved energy efficiency. So when it comes to the windows, you know, new construction and replacements, you have to meet your Title 24 energy code. So just a reminder, our code currently is a 0.30 for the U factor. And if you said you're gonna, you choose a window and you need a California code compliant window, you're gonna get that U factor. That's great. There are windows that do a lot better than that are available on the market. And then you can specify a solar heat gain coefficient for those clients who know that they still want to accept more of the heat through the glass. But this is where you get into that trade-off. And then just a kind of a sidebar, 2025 energy codes coming up. And so the U factor decreased for climate zones 1 through 5, 11 through 14, and 16. So that affects some of our tri-county areas like climate zone 4, for example, northern part of San Luis Obispo. And so slightly lower U factors required. But a lot of windows are available now, double pane, triple pane, and this is specifically, I'm going to let Mike talk about these slides because this is had a really low U factor, 0.15 windows, but the solar heat gain coefficient was low on purpose for this house. I'll point out. Go ahead, Mike. Tell us about this, and then the costing is the next slide after it.
Yeah, I feel like it's an hour into the TED Talk, and we could probably do another 2 hours just on Windows alone, and I can kind of go crazy on Windows. Bang for your buck, if you are working on a project and you're going to be working on Windows, we've found that it's by far the best thing you can do in your house that might be considered a little bit outside your par for the course normal everyday project. If you took your average builder with 50% of a clue and had them build their standard assemblies where they're not paying attention to anything, and you were able to get that builder to use a triple pane window or thermally broken window, just a better window, you're going to make a gigantic difference in the project, even if you didn't do all the other stuff. You still won't have a fantastic home if you don't do all the other stuff, but you're going to make a giant difference in their comfort. So we've put a lot of time, our own time, and in many cases, our own money and time spent researching the best windows to use for our particular projects, because you don't want to try to sell a client your project or your design and then have to come to them and say, hey, I know we got a quote from Anderson for 70,000, but I got these triple pane Zolas for 170,000. I think we should use those, because you've lost the design and you've probably lost the client as well. So we want to find windows that you can still hit budgets. Like our projects are still budget focused. We're not building mansions here. We do nice work for good people, but they don't have an absolute fortune of money to spend. We've had one of those and it was a lot of fun and we got to really flex muscles, but generally we're in, budget talks. So this was an old house, Cal Poly architect designed house from the 80s. We used to call it the Miami Vice House. When we first came in, it looked exactly like it belonged in Miami. Glass block, exterior windows. I don't know if they had a U factor. They let some accent lighting in the home, but really unfortunate situation. But it looked cool from the outside and probably looked cool for 1981 or whatever. So we removed all the glass block, and in this instance, this is a remodel. It's a California remodel. We did probably take out about 65% of the walls, but we did keep a lot of the exterior walls. And so we ended up padding out our 2x4 walls to make them 2x6 walls. And that had to do with insulation, as well as the fit of the window, as well as our client being a mechanical engineer and everything needing to be perfectly symmetrical throughout the house. So we didn't want to have a 2x4 versus a 2x6. And what we did was we effectively kept the existing window opening, change a few things around within the close vicinity, and then put in a, triple pane window. Um, I can tell you the brand. We're not brand associated. In fact, Jennifer and I are probably super against any kind of brand stuff. Like, we are just trying to make or help everybody build a better home. So I don't
Yeah, the
care what
brand's on the
brands
next
people
slide
use.
anyway, so,
Okay.
I mean,
So
do you want me just to go to the next one and shows the costing?
not yet. I want to make
Okay,
sure people notice that this is a big window. This is a 5 foot by 5 foot window, triple pane. It is heavy. It did take two of us to lift it into place. Um, it's not a nail flange installation. It actually has straps that you screw through the straps on the inside, which for your average builder will take them about 30 seconds to figure out the difference. And then they'll go, oh, okay, this is a piece of cake. And it's just a little bit different. Um, but this window tilts and turns in, and we actually we locked out the turn option on this one. We're only showing it in the photo for demonstration. You can actually put a lock on some of these handles so that it only tilts at the top. So it opens up about 6 inches at the top, and they can leave that open um, all the time. So, okay, next slide. So we do a pretty exhaustive cost comparison for clients. Uh, I try not to speak in absolutes, so I want to make sure we don't do this for every client now. We've found kind of a sweet spot for our particular projects, and we've found a couple manufacturers that we like to work with. One of the reasons you'll see like Andersons and Marvins and Lowens, those costs are pretty high, and they're good windows, but they do go through a pretty hefty series of dealers and wholesalers before they actually get to a job site. And we've found that with a lot of the window manufacturers who are coming to the table now, or at least visually coming to the table now, they've been around for 10 and 20 years in other parts, but they're really coming into California now. Um, they're basically direct to buyer. So you're working with a single representative from the actual window company where it's being manufactured, and then they are shipping directly to you. So they don't go through a series of wholesalers and then vendors before they get to you. In this particular project, we priced out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I actually think we had a few more. Um, we wanted to show the clients and we wanted to show the architect, because the architect wasn't sold either. This is an architect designed house, that we weren't pushing the budget to an extreme by giving them what we were trying to insist was going to be the biggest bang for their buck. This house is really glass heavy. And if they went with the typical dual pane 0.31 and or worse and somehow passed Title 24 via the performance, that this house was still going to be really uncomfortable. So we spent a lot of time educating these particular clients and this architect towards the windows that we chose in this project. And you can see a triple pane 0.14 Cascadia, 71,000 for the entire package. And the total condition floor area of this house is actually about 2,800 square feet. So that's a pretty good package for California for the homes. You can see the Andersons and Marvins and Lowens pretty high. I was going to say we even put the Zola on there. We did. Yeah.
yeah, okay,
Um, yeah.
I'm gonna move on because of the time.
Great.
And then we're gonna kind of pull it all together here with a little bit of more envelope stuff and then the batteries. Okay, so attic roof, a lot of us have crawled up into attics, and then we just look in there, like this project I worked on, looked in there and I was just like, oh my God, is this really an opportunity, or do we leave as is and deal with the bathroom remodel? So the questions to ask: are you going to be doing a roof replacement? What's the structural integrity? And then really, is there possibility to consider like WUI gable or dormer vents to kind of help the house just be more resilient? Okay, this project, a lot of times we'll go up into an attic and we'll see an existing like R19, and there's an opportunity to do blown in insulation over the top and bring the insulation up to speed so to speak, or bring it up to the current code. And then there is a caveat. Mike, I'll just kind of quickly tell the story and we'll move on to the next slides. But Mike had a project where the structural engineer said that the type of framing in this old house for the ceiling is that the cellulose would be too heavy. So that's something I think just to kind of keep in mind. So then you would want to consider other types of insulation that are lighter weight than cellulose, or look at some structural upgrades. The other thing is, on these type of projects, air sealing is the first thing. Before you put in a whole bunch of insulation, really you got to look at air sealing and do your best to get the air sealing. You also need to consider if there's existing light fixtures there, and is lighting replacement part of the whole remodel. And if the existing light fixtures are staying put in place and they are not insulation contact rated, you can buy pre-manufactured covers, or you can create them out of drywall and make sure that they're 3 inches above that project. And believe it or not, if you're doing a total attic ceiling remodel in climate zone 4 and even climate zone 6 and 8, but not 5, interestingly enough, which is San Luis Obispo. But in those other climate zones, you're supposed to bring up that insulation in the attic to an R49. And the reason is it's been shown to be cost-effective way and relatively inexpensive way to address a very large surface area of the home. Raised floors, kind of the same thing. You get in there, look underneath in that raised floor, and is there insulation existing? Is there moisture present? In this case, they even had their water heating and their furnace located in the crawl space. So it kind of double duties with that opportunity of, oh, are you replacing that system? And then what can you do to improve the floor space? If there's moisture, you can add a vapor barrier. You can look at making an unvented crawl space. So that's kind of, when you go down that road, you probably want to get some additional consulting from a knowledgeable builder, energy consultant, etc. In this case, we've got raised floor example. This was for an addition. I accompanied one of the HERS raters that we work with on a QII, and just kind of right off the bat, the first thing he noticed was, oh yeah, it looks like they did a lot of insulation in this floor cavity. So we went under there and he pushed up on it and he realized, oh no, the insulation was all down at the bottom of the joist, and it's supposed to be snug up against the floor. So they'll have to redo it. But as an architect on your drawings, you're going to want to show it and maybe really call it out that it should be snug to the floor of the insulation, and not just kind of down there at the bottom of the joist. When we have a raised floor, but an opportunity to deal with moisture mitigation at the same time, we're seeing more and more builders coming in and doing the class 1 vapor barrier on the ground, and then using a specialized tape and taping it to the foundation stem walls, and then taping it, cutting it properly to tape it to the concrete piers that might hold up that for the posts for intermediary supports. And then the picture on the right was a project I worked on. The picture on the left is one of Mike's projects where they went in there and installed that vapor barrier over the grade and used the ExoSeal peel and stick material around the openings, and then adhered it to the stem walls. And that is an easy way to start to address moisture issues in a project. And then there's a lot of opportunities to reduce air leakage. There's flexible tapes. You want to adhere to membranes. You can, on the interior, still do a continuous sealant at the sill plate, slab on grade and the stud walls. The picture on the right is a window installation from one of Mike's jobs where he calls out that you want to use your membranes and your continuous peel and stick flashings. That's your primary. The waterproofing and the air barrier should be from the outside, like the tape, like on the picture on the left. But sometimes you can't always do that, so you can fill the small gaps. Air seal them with foam. And then this slide, we've got kind of your ideal world. If you're tearing down the house enough, like Mike said, that California remodel, where you're really doing a lot of work, you can do the air barrier from the exterior. Then add your sleepers or your furring strips, and then apply your siding to that as a rain screen. And you do take that air barrier all the way down and have it attach to the foundation. That way the bottom of your bottom of your sheathing is part of now inside the air barrier. And then this next picture, these are from Mike's jobs. This one is from Mike's jobs. This is what it looks like if you're not doing something from the outside, but you can remodel the air barrier and do it from the interior. Technically, taped and sealed drywall is an air barrier, but in this case, they wanted to make the house very tight and then also do the HRV, ERV for really controlled ventilation. So they used a special membrane on the interior that's vapor open. It's just an air barrier, not a vapor barrier. They're different. So that's just an air barrier, but this way they could easily apply the air barrier material. Goes up quickly. You said it was super easy to install. That way it made the taping, drywall, the whole thing so much easier. You didn't have to worry about that being perfect for your air barrier.
Yeah, and the reason we did it on this particular house is a lot of the remodels that you'll do in California happen on homes that don't have sheathing. It's stucco over existing framing 2x4s. So rather than the cost of removing all of the stucco from a 1,500 square foot house and then sheathing the house and basically building a new house underneath an existing roof, we left all the stucco on the house and we attacked it from the inside. So we air sealed and insulated from the inside of the house rather than remove all the stucco.
Yeah, that seems like a really nice solution in that case. Okay, and then kind of, wrapping this back around to, as part of a lot of the remodels, a lot of the projects we're seeing headed towards more all electric, and then wanting the solar panels that pay for themselves to offset the electricity on some of the new all electric appliances they're getting. Then we're seeing projects where they're having solar installed and battery installed. However, a part of all this, part of moving towards all electric, is what's going on with the existing panel and is an upgrade needed. And sometimes you're going to be working on projects where this upgrade on the panel is in phases, and other times it's just straight off the bat, you're going to get a new electric panel with all the other equipment. So for my own project, for phase one for me was to get an EV charger for my car, to get the induction range and those heat pump space heaters. And that the electrician could come out and just redo some stuff on my old existing electric panel and find space for it and move some stuff around, combine some things, and I didn't have to get a new panel. But then as soon as I got the solar and the batteries, then the new panels wrapped into that whole project, which made sense for me. And so there's cost implications, you know, both ways when you talk to your clients and your owners. And so moving towards like a zero net energy home that's all electric or nearly all electric. You know, new construction's one thing. I just put this slide in here as kind of a visual on proportions of quantity of solar and battery for a 2,000 square foot home, for example, what code would require. But this is new construction. Remodels, it's going to be different. You can do what you want with a remodel. It's really up to what the client needs or wants. So for the existing home, you know, they're going to look at your roof, come out, bring all the equipments, and then kind of the question is too, when you do solar, is a new roof needed? Is it just roofing repairs? What type of roof? Because that can impact how the solar's attached. So that's just part of those questions and assessments and helping your client understand their desires and their budget. And then that can also tie back into the projects where are you upgrading the attic insulation and the roof insulation as well. And then the other part of managing client expectations is understanding like the occupant habits a little bit more. And in my own case, my house has 2 batteries and I sized everything so that I could most of the time have the solar and batteries meet my needs. And then what I realized is that when the teenagers, I still call them teenagers. Technically, they're not teenagers anymore, but they do laundry like they're teenagers. When they dry everything on high heat and they do laundry on high heat and they like do it all at once, in those days, my solar only meets about 60%. So I just kind of put it out there that some days, you know, just remind your clients they're still connected to grid energy. And so some days they're going to be using a lot more grid energy than they may expect, and they will still have an electric bill that comes from the main provider for their area. You know, if it's the community solar program, or if you're like on PG&E or SoCal Edison, whatever you have, you're still going to get an electric bill. But in my case, like my car charges on solar. And I have it set up so that it's smart. It's part of the system so that it knows to either charge the battery or charge my car when there's sunny days. So that even though I get the electric bill, I'm still saving about $100 a month because my car is charging on solar. Now, I don't drive that much. So I only save about $100 a month. So it really, again, depends on your habits. It could save you a lot more than that. And then this is a picture of Andy's house again, where they got the sub panel upgrade. They got the new panel now with the system that monitors those electric uses. And so now everything has been really cleanly labeled, and there's a monitoring system that works with it. So she can pull up that app on her phone and then really see how much is solar, how much is from the grid. She can do her car charging and start to evaluate and have some better indication of where their energy is going, and then look more at that time of use and when they want to, say, charge the car, or when they want to do something that's a higher electricity use and they could take advantage of the full solar. And then to get a handle on that for the remodel projects, if the house you're working on is within the PG&E territory, for example, PG&E has a tool, and you can get to it through guide.pgd.com. And if you want to be connected to folks that could give you pricing on solar, you can connect that button. But as designers and homeowners, you can also just go to their solar calculator and answer questions about your system or a system you'd like. And you can enter your utility bills, either actual or monthly kind of average costs. And it can help you determine where a break-even point is, and based on system financials that you can input, do based on like average costs of battery and solar, it can start to help you figure out if solar only or solar and storage is worth it, and help you understand what the payback will be on that. So I think that's a super useful tools for remodel projects. And then to kind of wrap us up, and we'll have a couple minutes for questions, is we are code coaches. And so please, if you've got code coach questions, call the number or go online. And Chloe, you're going to tell us about some upcoming courses, and then we will have a couple minutes for questions.
Yes, thank you so much, Jennifer. Thank you, Mike, for being here. This was great, and I'll keep this super quick so we've got a little bit of time for questions. If you signed up or checked the box when you registered to receive AIA learning units, I will be distributing those. If you have any questions about that, please send me an email. My email's on the slide. You will be getting the slide and the recording for today's training sent to your email that you registered with, along with the survey. It really helps us if you fill this survey out. So if you are, maybe if you come to these trainings a lot and you haven't filled the survey out yet, this is your opportunity to give us some feedback, what's working, what's not. And then we also have a bunch of really exciting upcoming courses. I won't talk about all of them, but I will pop in the chat the link for our calendar of all of our events. So take a look at that, see if anything interesting is coming up. I'm definitely going to promote, we have an in-person event in Santa Barbara coming up, an all-electric ADUs course. This is going to be at CEC's Environmental Hub on State Street in Santa Barbara, Friday afternoon. I think it'll be a lot of fun if you're looking forward to a little bit less Zoom, a little more in person. Sign up, space is limited. I think it'll be a lot of fun. And then we also have Mike coming back for a builder's perspective on zero net energy at the end of May. And that's all I have. So I'll hand it back to Mike and Jennifer for questions.
Yeah, and thank you. And anything in the chat, Mike, maybe I missed or we didn't address? And also feel free to unmute if anyone has a question.
There are a couple questions. Cody asked for the name of the company that does the conversion for the wood burning range to the induction. Shoot me an email and I'll find that. I know we have it in our files. I don't have it offhand. Julie said that she tried to get, I hope it's okay for, I think Julie likes being called out in these workshops and stuff. So, cause I know she does a lot of this work. So, she had a builder price out Alpine fiberglass windows versus the usual suspects, and Alpine was about 50% more than the others. Obviously, not knowing the 200,000 aspects to the full conversation, I don't know who the usual suspects are, and I know that Anderson has a builder grade, and then Anderson has mid grade, and Anderson has high grade, and in between there they have different levels of all those. And Marvin will have the same thing, and Lowen will have the same thing, and I've used all of them, so I don't want to sound like I'm, it's hard work. It's hard work to do any of this stuff. So anything we can do and still keep doing our jobs is great, but there could be a big apples to apples comparison. My first instinct was someone asked the builder reached out to their window supplier. The window supplier said, we can get those. And they reached out to Alpine, and then Alpine comes back to the window supplier and those are upgraded 100%. And then the window supplier reached out to the builder and those are upgraded another 50%. And then the builder supplies them to the homeowner. So there could be a million chain of events that are happening there. We find Alpine to be a very builder grade, like very budget. We're almost not using them in our projects anymore, to be honest, unless budget is 100% the driving factor. Could do a workshop on that.
Last,
I
did you
think
see that
Andy answered
comment
the other
about Sierra
questions.
specific?
Yeah, I mean, I have a million thoughts on everything, and I know Jennifer does too. So, Sierra Pacific are beautiful windows. I mean, they're really pretty. They're good energy performance. I know a lot of, I don't want to say community, but the passive house centric world likes Sierra Pacific if they're not going for a certified window. I mean, they're beautiful. So, yeah, good job. We've priced them out on a bunch of projects. It's just never managed to work for a couple different reasons. But Robert's saying, seems that improving the envelope of an uninsulated house is one of the stickiest improvements, both in terms of cost and disruption. Am I right? Well, yeah, I guess it depends on the scale of the remodel. Is it an aesthetic focused remodel? Is it, kitchen countertop and cabinets, or is there an energy purpose to the remodel? We wouldn't approach anybody with um, addressing the envelope if that wasn't part of their concerns that we identify at the beginning of the process. We'd be sitting with them, and if they're saying, well, we want a bathroom remodel, and we ask why. Well, our floors are just freezing. It's always cold. The shower's cold every time we get in the morning. And then we can say, well, you're probably over an uninsulated crawl space, and your ground is about 50 degrees. So your floor is about 50 degrees, if not colder, all the time. So yeah, it's one of the more expensive things to do.
Right. But
You can
also,
spend, oh, sorry.
oh, I was
I
just
was going to
thinking,
say
we
you
didn't,
could spend 50
yeah, go
grand on
ahead,
a
go ahead.
kitchen.
We both
You could
talked.
spend 50 grand on a kitchen, 11 grand on a kitchen, or 150 grand on a kitchen. So part of the process of the evaluation.
Yeah, and then we didn't show a picture of it, but most of the pictures we show are more of like, oh, take off the drywall, do this, do that. And even that one where the homeowner tore into the wall and was like, I have an uninsulated house. The thing is that budget dependent. Like there was a extensive remodel I worked on here in San Luis Obispo, but the solution for the uninsulated walls wasn't to tear off everything, because it was a true plaster interior and plaster exterior on the old house. And so they very carefully weighed with the builder, should they do it from the interior or exterior, but ended up drilling holes. They chose the exterior after all, because they wanted a new color on the outside and just a new refresher skim coat, color coat. And so they drilled holes top, bottoms of walls, and sometimes they had to do intermediate holes, but they pumped in blown in insulation and made sure it all reached the bottom. And they were able to use like thermal imaging and kind of find those studs and do those bays. And that was way more affordable than tearing everything apart. And so they still got the benefit of the insulation. So there are things like that that can be done.
A lot of factors to weigh on the approach that you take to the projects. Doing an exterior wall where you're taking apart the stucco and it's a remodel, if the clients are living there, that is not a very pleasant environment to be around while stucco is being jackhammered off of houses and loaded into dumpsters. It's really messy, really dirty, really heavy, versus the approach we took on the interior. Now you're balancing, well, can they move out for a couple weeks? And in that particular instance, and then what's the cost of them moving out? In that particular instance, we worked around a summer vacation. So we knew it was summer season, and we had 30 days, exactly 30 days to get in, get the interior walls down, get them insulated, get them air sealed. We used caulking first, get them insulated, then our air barrier over the walls, get the blue board back. Sorry, I say blue board because that's the New England term. Get the drywall back on the walls and get them finished before they move back. And we finished as they pulled up in the driveway. Our cleaning crew was wrapping up. So there's so many factors to balance through the course of evaluating what approach you'll take.
Yeah. Okay. Mike and Chloe, I think we should call it because we do want to let folks get on with the rest of their day. And I so appreciate everyone being on the call, and thanks for the great questions, and thanks Chloe, and thanks Mike, and thanks Andy for your pictures.
Thanks everyone for being here, and we hope to see you on a training coming up soon. With that, I'll let everyone get back to their day. Bye.
Thanks all.
Bye. Thank you, everyone.